Researchers have found a never-before-seen anomalous structure near our Earth's core. Here is how they did it. Geophysicists from the University of Maryland analyzed seismic waves around the world and found large, unusual structures near the Earth's core. The study was published on June 12th in the journal Science. The team of researchers analyzed 7,000 seismograms from earthquakes of 6.5 magnitude or greater that occurred from 1990 to 2008 using Sequencer, a machine learning algorithm. They specifically searched for echoes of seismic waves known as shear waves or S waves beneath the Pacific Ocean basin. The results uncovered an anomalous structure under the volcanic Marquesas Islands in the South Pacific. The results also showed that a previously known structure beneath the Hawaiian Islands is much larger than had been thought. But what is this other large structure that they found? Well, the thing is, they don't know for sure, but they believe it is likely an extremely hot and dense rock. Co-author of the study, veteran Lykek, said in a press release, "This is really exciting because it shows the sequencer algorithm can help us to contextualize seismogram data across the globe in a way we couldn't before." Speaking of weird things about our planet, a mysterious anomaly in the Earth's magnetic field that stretches from South America to Africa is spreading, and scientists do not understand why. New data from the European Space Agency's Swarm constellation of satellites show that a weak spot in the Earth's magnetic field known as the South Atlantic anomaly has been growing in size since 1970 and may possibly be developing a second cell centered above the coast of Southwest Africa. The Earth's magnetic field, which is generated by the dynamo action of its molten metal core, protects the planet from the full impact of solar and cosmic radiation. According to the ESA, over the last 2 centuries, the global magnetic field has lost 9% of its strength on a global average. For now, the most significant effect of the weakening of the South Atlantic anomaly is interference with satellites and spacecraft that pass over the region. However, the Earth's magnetic field destabilizes and reconstitutes itself over geological time, with sometimes even the north and south magnetic poles trading places. According to the ESA, it is not clear what is causing the weakening of the South Atlantic anomaly, but it could be related to the African Large Low Shear Velocity Province, one of 2 giant underground masses of rock that float like hidden continents where the Earth's mantle meets the outer core. Further observation and understanding of the South Atlantic anomaly could, according to the ESA, help scientists understand more about what is happening in the scarcely understood processes of the Earth's interior that drive these changes. Geophysicists may have found out why the magnetic north is moving faster and faster toward Russia. Disappointingly, it has nothing to do with Vladimir Putin's rugged charms. The Earth's north magnetic pole has been shifting its position from Canada to Siberia, and since the 2000s, the movement has been picking up speed. According to a new study, scientists now say they may understand why the pole is moving. Writing in Nature Geoscience, the scientists say there are jets of molten material in the outer core of the Earth, and alterations to the flow are moving the north magnetic pole. According to the paper, researchers utilized the European Space Agency's Swarm satellites to collect the magnetic data needed for the study. Citing the authors, BBC reports the molten jet is located much further south than the researchers originally thought in their presentation to the American Geophysical Union 2 years ago. The study's lead author is cited as saying that the flow made the Canadian magnetic node weaker in relation to the Siberian node, which causes Russia to win the subterranean tug-of-war for the magnetic North Pole. According to the authors, the study's results were incorporated in the updates for the World Magnetic Model, which is used by the navigation systems on everything from ships to cell phones. In a news statement last year, the authors state that, quote, "The wandering pole will likely interfere with navigation in the region and necessitate frequent updates to the model."
A study published in JGR Solid Earth says that it is snowing iron at the Earth's core because molten iron crystallizes in the outer core before the substance sinks downwards. The University of Texas at Austin said in a press release that these iron particles form a 300-kilometer layer above the Earth's solid inner core. The paper states that the iron snow in the core is comparable to what occurs in magma chambers, where minerals crystallize out of the melt and congeal into rocks. The study said that the team led by Sichuan University associate Professor Zhang Youjun analyzed seismic wave signals to infer the composition of the Earth's core. The university says the scientists found seismic waves propagating slowly in the outer core's base, but quickly in the eastern hemisphere of the top inner core. The researchers believe that the varying thickness of the iron slurry layer is the cause of the speed difference. They theorize that the iron particles have the effect of slowing seismic wave travel and that the substance is thinner on the inner core's eastern hemisphere. According to the researchers, the Earth's core drives tectonic plate movement with its heat and generates the magnetic field around the planet. The researchers say that understanding the composition of the Earth's core may shed light on those larger processes.
For more news animations and explainers, hit the subscribe and bell button to join the Tomo News family. Thanks for watching.